Good morning, students. Next problem, 54th. In this you are given a square wire of side, means square side is 3 centimeters. He is placed at a distance 25 centimeters from concave mirror. Nature of the lens or mirror, you need to be careful what type of mirror. Of focal length 10 centimeters. Find the area of the image formed. Find the area of image. This square wire 3 centimeter by 3 centimeters. So area of the object becomes equal to 9 centimeters square. It is a distance equal to u. They told that in the middle is kept means the image is formed also middle at the some distance v is the image is formed at this object image is formed at distance v from the mirror. Concave mirror focal length is left side focal length, therefore it is minus 10 centimeters and object distance is 25 centimeters. Here it is given minus 25 centimeters, it becomes left side. A square wire side is 3 centimeters. Area of the object is AO, we are taking L square equal to 9 centimeters square. Area of the image is AI, I am taking, we have to find out that. 1 by F equal to 1 by U plus 1 by V formula we have for the mirrors. The focal length formula relationship and magnification formula directly, if you remember this formula, it is always better to which save the time for you for the mirrors. This is for mirrors is F equal to M equal to F by F minus U. This for mirrors. Then F is given as minus 10, substitute the values minus 10 F value and U is minus 25, minus into minus becomes equal to plus 25 here, minus into minus becomes equal to plus 25, plus 25 minus 10 becomes equal to 15. So 10 by 15 becomes equal to 2 by 3. Negative sign indicates what is inverted image only. If you don't remember this formula, you have to take the 1 by V you can find out, and magnification equal to minus V by U formula also you can take it, or from this formula how to get this relation is multiply throughout with U, because U is given for us, multiply throughout with U. Sometimes if they give V, multiply throughout with V. U if we multiply, no, U by V, U by U is 1, U by V is nothing but equal to 1 by magnification minus half. So U by V you will get the relation separated as with LCM you take corresponding to the M equal to minus V by U. If you get the expression, you will get this relationship for you. Next is after substitution magnification of the, this is called as the linear magnification. This is called as a linear magnification. Lengthwise, just lengthwise and distance and height wise also you can take. This is length and height. It is also called longitudinal and lateral magnifications. Formula is similar, minus 2 by 3. Minus 1 indicated that inverted image. Don't bother much of that. Because you are taking the aerial magnification. Aerial magnification is, area means all the length into breadth square, you have to take the relationship. So magnification of the area, aerial magnification is square of the linear magnification you have to take. Square of the linear magnification is equals to area of the image by area of the object. Aerial magnification is also area of the image by area of the object you will take. So linear magnification card is 2 by 3, squaring it, minus don't bother with it, minus square becomes equal to plus only. And area of the image area of the object equal to 4 by 9 it becomes. 4 by 9 is area of the image by area of the object. But what is the area of the object is given as for us 9 centimeters square. So this area of the image by 9 equal to 4 by 9, 9 cancels. So area of the image is 4. Same units you have to take. Area of the object is centimeter square, area of the image is also in centimeter square you have to take. Next problem is 65th one. These two problems are important for the NEET and JEE, mainly for JEE. NEET, this aerial magnification can be asked. This one important for mainly for the JEE cases. Here object is the mirror. Object is moving towards the concave mirror of focal length 25 centimeters. Concave mirror focal length is 25 centimeters. 24 centimeters. When the object is a distance equal to focal length is 20 centimeters, but object distance is 60 centimeters. So what you get is a real image. This is the focus. U is greater than F means you are seeing the real image. Object is moving or person is moving towards the mirror, we can see, and image will be moving away. When U decreases, V increases. Object is a distance of 60 centimeters. First U is 60 from the mirror. The velocity it's moving means velocity is VO will take. Velocity of the object is this side. Is equal to 9 centimeter per second. Find the speed of the image at the distance. Find the speed of the image. Image is going in the opposite directions. VI, VO. V and U for the object image distance is VI, VO. Velocities we are taking. These are nothing but equal to velocities. Next basic formula for the mirrors, 1 by F equal to 1 by U plus 1 by V. So if you take 1 by V, this becomes equal to 1 by F minus 1 by U relationship. 1 by V equal to 1 by U take to the left side becomes a negative. From this you have to find out the value of V. the V substitution out for substituting the values. I didn't mention the values here, no space for that. For this problem, concave mirror, focal length is equals to minus 24 centimeters left side, and object distance u is equals to minus 60 centimeters. This is a object distance. V we don't know, we have to find out, that is image distance. Next, velocity of the object u is 9 centimeter per second, velocity of object towards the mirror, so we'll take it as a plus. Towards mirror, right side distances, we take it as a plus. Towards mirror, VO, velocity of image, we have to find out this is how much. Actually, it will be going opposite directions, negative you have to get. From this, first you have to find out the object distance. Object distance given, no, image distance you have to find out. V we have to find out. While V what you get is 1 by f equal to 1 by u plus 1 by v relationship substitution. V you will get it as equals to minus 40 centimeters. So while getting this V is equals to V equal to minus 40 centimeter. This is the image distance. Okay, next what you have to do is we have to find out the velocities relation. For the velocities relation what you get, so I am writing this value. We are getting the value as minus 40 centimeters is what we calculated. Velocity of the object we need to find out. For that purpose what you take is that same equation I am writing here. 1 by f equal to 1 by u plus 1 by v. Take this u and v to the numerator. 1 by f is equals to u minus 1 plus v minus 1. To get the velocities, no, these are the distances or displacements. Differential of the velocity displacement is nothing but equal to velocity, but f is constant in this expression. Focal length of the mirror is not constant, so differential of the constant is 0. So our differentiation becomes equal to differentiation. This equation becomes equal to 0. Differentiation of this term becomes equal to minus u minus 2 into du by dt minus v minus 2. Differentiation of v minus 1 is minus into v to the power of minus 1 is minus 2 into dv by dt. Again differentiation with respect to time. Distance by time it is. Distance by time is displacement time is nothing but velocity or speed we can take in this right hand part. 0 equal to minus u square into velocity of the u means object minus v square into velocity of the image. This minus 2. Take it to the numerator. This becomes equal to VO by minus of course u square. This is minus VI by v square. VO by u square, velocity of the object by object distance square, minus you can take out common also if required, velocity of the image by velocity distance square. Lenses also they may ask you me similar procedure you have to follow. Concave mirror, convex mirror, this is the basic relationship. At the end we can values given means you have to put the sign convention. Take it to the left side. We want the velocity of the image. So what you get the relation is velocity of the image by v square plus it becomes minus VO by u square. So velocity of the image we want is equals to velocity of the object by u square minus of course into v square u. This is a relation for the velocity of the image. Okay, that same thing I have written here. That small portion not required. Velocity of the image equal to velocity of the object by u square into image distance square. Substitute the values into this. So what to get the relation for answer is velocity of image Vi is equals to velocity of the object is given as, that is sorry, 1 minute, somewhere mistaken, this is a UO will take. Velocity of the object we will take it as a UO or a VO, that is left to your choice. I mentioned here as UO, so we will take it as UO. Velocity of the object is nothing but equal to UO, that means minus 9 by object distance square. Object distance is 60 into 60 into image distance square. Image distance is 40 into 40. Square is there, means minus to minus becomes equal to plus. 0 0 0 0. 3 3s are 3 2s are 3 2s are 2 2s are 4 cancels. Result is 4 units. Whatever the units are given for the object, no, centimeter per second. This is also centimeter per second. Minus comes. Negative sign indicates what is away from mirror. If the person is moving away from the mirror, then object moves towards the mirror. Just opposite direction of the motion you have to take. This problem is also important for JEE. You have to remember the relationship directly from this relation for the mirrors or lenses, or you can easily differentiate and get the expressions required. Question number 67. This is important for CET also. Last year also they asked. At CET, NEET, JEE, for all exams it is important. Two plane mirrors A and B are arranged in this problem. Two plane mirrors are there. A and B. This A, B. Kept parallel to each other. Length of these mirrors L is equals to 2√3 meters from here to here. And the separation is D. D is equals to 0.3 meters. One light ray is falling, incidenting at the tip like this at some angle. The angle is 30 degrees. That is theta I will take. 30 degrees. A, B. Parallel plane mirrors. Separation D. Length L is equals to 2√3 meters. Separation equal to 0.3 meters. Maximum number of the times the light ray undergoes reflections, including the first one, before it emerges out is, find number of reflections, number of times the light reflected, reflections of light between mirrors. Ray incident theta equal to 30 degrees for incident ray. They will give you the diagram, of course. Is light incidenting, light ray. You have to follow the laws of reflection. Laws of reflection is what? Angle of incidence equal to angle of reflection. So whenever the light falls here, it will reflect like this. This angle equal to this angle. This is also equal to theta 30 degrees. This is the distance covered in the first reflection. Again it reflects back. Angle of incidence equal to angle of reflection. You will get the same angle here, 30 degrees. So this is also theta and theta. Like this process goes. That means what you get here is this one length travel, this is the second length traveled, this is the same place. Second length travel. Like that you take goes on reflecting multiple times. Finally comes out. Before coming out, how many reflections are taking place? You just calculate how much is this distance covered in one reflection. For one reflection, distance covered is x. So L is supposed to be equal to n into x times. You have to take the total number of reflections. Distance covered in one reflection or for one reflection is x. I'll write it as x equal to in one reflection. So this is at 30 degrees. This is a d, we know it. This is a d. We have to find out this value. This is adjacent value. Tan 30 we can take. So tan theta is equals to x by d. Tan theta equal to x by d. Instead of this, they may give the different values. Use this relationship. Theta is 30 degrees. That what you get here as d is also known for us. X you have to find out. X is equals to d into tan 30, which is equals to d is 0.3. 0.3 into tan 30. Tan 30 is sin 30 by cos 30. Sin 30 is half, cos 30 is root 3 by 2. So 1 by root 3. These are x values. So 0.3 by root 3 is x. Next is we want to find out number of reflections. So length L is equals to n into x. This is total length. L equal to number of reflections into x. L is how much is where n is number of reflections between the mirror. So L is nothing but equal to 2 root 3 equal to n into x is 0.3 by root 3. So n is equals to 2 root 3 into root 3 by 0.3, which is equals to, this becomes equal to 2 into 3 by 0.3. I think I went through some mistake. 20 I am getting? No. Data, sorry. This d is d 0.2 meters given. Not 0.3, it is 0.2 meters, sorry. This is a 0.2. This is 0.2. 0.2. So root 3 into root 3 is 3 by 0.2, which is equals to 2 into 3 into 10 by 2. 2 cancels, so it is number of reflections equal to 30. If they give this as a 0.3, no, you will get as a 20 reflections. That is the answer. Next to 68. This is also important for NEET and JEE, but rarely can be asked even for CET also, CET. Previous one is 67, this is 68. A luminous object is placed at 20 centimeters from the surface of a convex mirror. Object is at, luminous means producing light, means a bright object. Luminous object is placed at 20 centimeters from the surface of convex mirror. It is a distance of, is at a distance of 20 centimeters from convex mirror. From convex mirror. And one more, plane mirror is also set so that virtual image formed by the two mirrors coincide. Plane mirror is kept a distance 12 centimeters is kept at a distance of 12 centimeters from object. A distance of 12 centimeters from object, and in front of the mirror. You have to keep between object and mirror. Place it between object and mirror. Okay, I will draw the diagram corresponding to that. Find the focal length of convex mirror. Convex mirror. It is arranged such that what images of the two mirrors coincide. If images of two mirrors, one is a plane mirror and another is a convex mirror, coincide. This is an important problem. Convex mirror here now. Virtual image is formed always within the focus. There is a focus we can take. Okay, that is not important for us now. This is a convex mirror, and one plane mirror is also kept in front of it. This is a plane mirror, and object is kept at some distance here. What they told is object is at a distance of 20 centimeters from the convex mirror. This object, this at a mirror's distance is equals to 20 centimeters, and plane mirror is kept at a distance equal to 12 centimeters. This is at 12 centimeters. So what is the distance between these, difference between these two becomes equal to 20 minus 12 is 8 centimeters. This we have to find out. This is going to be 8 centimeters. For the plane mirror, object distance is equal to image distance. This is a plane mirror. This is a convex mirror. For the plane mirror, object distance is equal to image distance. What they told is, for this concave mirror, image is formed, and for the plane mirror also image formed, but both are equal distances. These are images. Two images are coinciding, means one appears to be above other. One appears above the other and just close to this. If they are not formed at the same point, how do you know they are coinciding? When you are looking from here, you will see the images. In this mirror also you will see image. You take this pin little bigger or object bigger than this. Half image here, remaining half you can see this portion. So two images are seen here, and two images are coinciding. How do you know? Is with a single eye you have to see. Single eye you have to see. If they are not coinciding at the different distance formed also, they appear to be coinciding. They are in line appears. But move your eye to the side, you will find the gap between these two images means they are not at the same place. If you move your eye also, the images are not, the separation is not taking place. Image separation not taking place means they are formed at the same point. So two images are at the same point. How do you know? Is move your eye to the left and right. If you move your eye left and right, both images may move, shift slightly. Then together they move. Together moving means they are at the same place. In case if they are not forming at the same place, one is here, other is here. By seeing from the straight line, they appear to be coinciding. But if you see from the side, you can see the gap between these two. That means they are not at the same place. At the same place means image coincides without parallax error. Shifting the eye related to the parallax error, a parallax adjustment. So now object distance equal to image distance. That means this is supposed to be equal to 8 centimeters. Now we got the image distance. This is also equal to V. This is U, this is V. This is for the mirrors, plane mirror, concave mirror, convex mirror we are taking U and V values. For the plane mirror, directly we are calculating it. It is convex mirror. Focal length is equals to minus 20 centimeters. And object distance, a distance of 20 centimeters from the convex mirror. Sorry, we have to find focal length. We have to find out the focal length of the convex mirror. F is not given. F we ought to find out. U is given. U is minus 20 centimeters. Next, plane mirror. For plane mirror, object distance equal to image distance. Equal to image distance. How much it is equal to is 12 centimeters. Sorry, 1 minute. This object distance equal to image distance. This is 12. So totally is supposed to be 12. This is 8. This is 4 centimeters. Object distance equal to image distance equal to 12 centimeters. Next is for the convex mirror, we have to find out, we know the image distance. Image distance equal to 4 centimeters. Find out focal length. Therefore, from figure, you have to draw the rough sketch of the diagram. Therefore, from figure, image distance V equal to, right side no, plus 4 you will get, a rotated image for convex mirror. Now we know the formula 1 by F equal to 1 by U plus 1 by V. Find out F from this. U is equals to minus 20 centimeters. So 1 by F is equals to minus 1 by 20 plus 1 by 4. Calculation of this will give you F is equals to, focal length of the lens mirror is 5 centimeters you have to get. Right side no, you have to get plus only. Check up the calculations. Next question is 70th question. Plane mirror is placed in the visor plane. Write it here. Plane mirror is in visor plane. Plane mirror is visor plane facing towards negative x-axis. Facing minus x-axis. Mirror is moving parallel to y-axis with a speed of 5 cm per second. Mirror is moving along y-axis at 5 centimeters per second. Point object P is moving in front of the mirror with a velocity of point object in front of mirror is 3i 4j 5k centimeter per second. This is the velocity of the object is 3i 4j 5k centimeter per second. They may give 3 centimeter per second into I, j, like that, no problem. This is plus 4. centimeter per second. In this, you have to find out the velocity of the image with respect to the mirror, they told. With respect to the mirror, image velocity, the object velocity, sorry, the image velocity and is equals to object velocity, we have to get same values with respect to mirror. But with respect to object, if they ask, no, opposite direction, if it is moving, then twice, relative velocity, take it as a twice the velocities with respect to object, same velocity with respect to mirror. But here, velocity of the object is in terms of the 3 dimensions given, x, I, j, k terms. Velocity of the mirror, this is the velocity of the mirror, is along the y-axis, they told. Mirror is moving like this. If you are standing in front of the mirror and mirror is moving towards you, away or at some other angle, you will find the effect in the velocity of the image. But if the mirror is moving up or down, you will not notice the motion of the mirror itself, because image appears to be stationary. If you are stationary, image is stationary. So velocity of the mirror along the y-axis is, this is not considered. Velocity of the mirror along the y-axis is not considered. That is not at all affected. Next is, which velocity is affected here? That velocity you have to consider perpendicular to the mirror only affected, you have to take. Which component of the velocity is perpendicular to the mirror is 3 meter per second. If mirror is like this and if the object is moving like this, VO, then image will be here. This is the image velocities. Object is moving to mirror, image will be moving like this. But the person seeing the image is nothing but equal to affected values. Is always perpendicular direction you have to take, these directions. If the object is moving towards the mirror, the image is moving in the towards the mirror backside, means towards the object. But here the velocity of the object is 3 meter per second. That part only reverse you have to take. If object is moving towards, means image appears to be backwards. Plus 3 means towards the mirror, image will be appearing minus 3. Only this part you have to reverse, remaining is not at all affected. So consider velocity perpendicular to the mirror only, which is reversed. Velocity of the image is minus 3i. Plus 3i means minus 3i, remaining not affected, 4j, 5k. Units is same, centimeters per second. And only x component of velocity is reversed in this case. Only in this problem, x component is reversed. That is a perpendicular to. It is perpendicular to mirror. Already mentioned here. Perpendicular mirror only you need to consider. Okay, we will stop now.